Welcome back, everyone. Today we're going to learn about solving systems by elimination. Sometimes you have to use algebra to solve a system, but using substitution would force you to deal with fractions or decimals. A second method to solving using algebra is called elimination. To solve using elimination, your goal is to eliminate one of the variables. To do this, you need to make one set of variables opposites. So, here are simple steps that you need to follow when solving a system by elimination. Number one, make x or y opposites by multiplying one or both equations by a number. Two, add your two equations together. You're going to add vertically each time. One of your variables should cancel out. 3, solve the resulting equation using algebra. And number 4, you substitute the value of x or y you just found into one of the original equation to find the value of the second variable. So, what I mean by make x or y opposites. So here, let me go ahead and give you an example. So if I were to say you have a number 2, what is the opposite of positive 2? Well, you would say negative 2. So the opposite of positive 2 would be negative 2. And if you were to say negative 7, what's the opposite of negative 7? You would just say positive 7. These are what we call opposites, right? So if I were to give you a more specific example or two, let's say I give you something like 2x, the opposite of that would be negative 2x. And if I said negative 5y, then you would say the opposite of that would be positive 5y. So we are going to be working with systems. If I were to give you something like this, I'm just making something up. Here is a system of equation. So we have two equations here. I have 2x plus 5y equals 10 and negative 2x plus 6y equals 15. So when I'm looking at these two equations, I'm going to look at the x's and the y's. If you look at the 2x and the negative 2x, okay, both of them are x's and both of them are opposites. So when I'm adding these like terms vertically, of course we're going to be adding like this. 2x minus 2x, or 2x plus negative 2x, that's going to cancel out. And then you have 5y plus 6y, which is going to give you 11y equals 10 plus 15, that's 25. Right? So the first thing that you have to do is you make sure that you create your opposites, and then you're going to add, and then you're going to solve. And once you solve for the variable, you plug into one of the equations and solve it for the other variable. Because remember, our goal here when it comes to solving systems is to get an ordered pair. That is the solution to the systems, right? Now, it's not always the case that you have opposites immediately, right? And you're going to have to figure those opposites out, because if I were to say something like 2x plus 5y equals 12, again, I'm just making these equations. They're not going to be perfect at all. And you have 4x plus 7y equals, I don't know, 25. Well, right off the bat, you don't have your opposites, right? So what should I do here? Well, I'm going to pick either x or y to eliminate. And I'm just going to start with the x, because this is going to be a lot easier, and believe me how I'm going to do this. Okay, so look, I have 2x and 4x. If I were to multiply this whole equation by negative 2, right? That means I have to distribute the negative 2 to each term, just like this. Well, what's going to happen? Well, negative 2 times positive 2x is going to give me negative 4x. 4x plus 7y equals 12. Again, I'm just making these equations. They're not going to be perfect at all. And you have 4x plus 7y equals 25. Well, negative 2 times positive 2x is going to give me negative 4x. 4x plus 7y equals 12. Again, I'm just making these equations. They're not going to be perfect at all. And you have 4x plus 7y equals 25. 4x plus 7y equals 25. Well, negative 2 times positive 2x is going to give me negative 4x. 4x plus 7y equals 12. Again, I'm just making these equations. They're not going to be perfect at all. And you have 4x plus 7y equals 25. 4x plus 7y equals 25. Well, negative 2 times positive 2x is going to give me negative 4x. 4x plus 7y equals 12. Again, I'm just making these equations. They're not going to be perfect at all. And you have 4x plus 7y equals 25. 4x plus 7y equals 25. Well, negative 2 times positive And then negative 2 times positive 5y, that's just going to be negative 10y, equals negative 2 times 12, that's negative 24. Right? So now, let's go ahead and compare this equation to this second equation over here, which is 4x plus 7y equals 25. And look at that, we do have opposites. Now, this here, what I did was I would just multiply by negative 2. I was multiplying by a number so that I can create opposites, right? And you're able to do this because if you multiply by a certain number, whatever you do to one term, you need to be fair and do that for the rest of the term. So I'm multiplying each term by negative 2 by using the distributive property, which is totally fine as long as you make sure that you compensate or balance the equation. Okay, so going back to this over here, of those two equations, and of course you notice that I can cancel both of these x's and then add vertically, right? So I can add these two terms and these two terms, solve, and do the rest of the steps shown over here. All right, so we're going to go ahead and do some examples. Let's take a look at number 1. I have 2x plus 3y equals 34, and 4x minus 3y equals negative 4. And right off the bat, I can definitely see the positive 3y and the negative 3y. Those are opposites. I can actually cancel these two terms out. And then I'm just going to add vertically. So 2x plus 4y, that is 6x, equals 34 minus 4, which is 34 plus negative 4. Or you can say 34 minus 4, it's the same thing. 34 minus 4 is 30. And then I do algebra. I'm going to divide both sides by 6. I get x equals 5. So I found my x value. Now what I need to do is I need to find my y value. So what you need to do here is you're going to take your x equals 5 and plug it into one of the equations. You can choose 2x plus 3y equals 34 or 4x minus 3y equals negative 4. Let's go ahead and just plug it in to the first one, the first equation. All right, so 2x plus 3y equals 34. So if I know that x is equal to 5, then I have 2 times 5 plus 3y equals 34. Then I have 2 times 5, that's 10, plus 3y equals 34. Subtract both sides by 10, because the goal here is to solve for y. So I have 3y equals 34 minus 10, that's 24. Then I will divide both sides by 3. So I will have what y equals 24 divided by 3 is going to be 8. So I have x is equal to 5, y is equal to 8. Form that as an ordered pair. That is 5, 8. That is the solution to this system. Moving on to number 2, we have x plus 6y equals 1 and 3x plus 5y equals negative 10. Number 1 was pretty easy because step 1 was already done. We already have our opposites. However, with number 2, we don't have the opposites immediately. So remember, you're going to choose which one you want to eliminate. In this case, I'm going to eliminate the x's, and I can show you why. I'm going to make sure that when I am manipulating this, I am multiplying by a number that is negative because, look, this is 3x. That's positive 3x to be exact. If I multiply each term in this equation by negative 3, well, let me go ahead and distribute the negative 3 to each term. This is going to become negative 3x minus 18y equals negative 3. And then rewriting the second equation of 3x plus 5y equals negative 10. I have opposites already, so negative 3x plus 3x will cancel out. Remember, we are adding vertically. So negative 18y plus 5y is going to give me negative 13y. And then negative 3 minus 10. You start negative and you're tacking on more negative. That's going to be negative 13. Now, let's divide both sides by negative 13 because we are going to solve for y. And what you're going to get is y equals negative 13 divided by negative 13 is positive 1. So you know that y is 1. So what do we need to do now? We need to find our x value. So we're going to take our y value and plug it into one of the equations. I'm going to choose the first equation here. So x plus 6y equals 1. If y is equal to 1, then we have x plus 6 times 1 equals 1. So x plus 6 equals 1. I'll subtract both sides by 6. And then I will get x equals negative 5. So as an ordered pair, the solution to this system is negative 5, comma, positive 1. Number 3, we have 2x plus y equals 8 and 6x plus 3y equals negative 15. This time, I'm going to create my opposites by focusing in on the y's. So let's see what happens when I do that. So I will multiply each term by negative 3 and then apply the distributive property here. Negative 3 times positive 2x is negative 6x. Negative 3 times positive y is negative 3y. And negative 3 times 8 is negative 24. And then I'm going to rewrite the other equation. So 6x plus 3y equals negative 15. And then I look closely. Okay, so I notice that the x's and y's both have opposites, right? So let me go ahead and show you what happens when I add vertically. So negative 6x plus 6x, that's 0. And then negative 3y plus 3y is also 0. So I'm really dealing with a 0 plus 0 situation, right? So both of the x's and both of the y's, they cancel out at the same time in this problem, right? So the left-hand side is 0, and then don't forget, we still have the constants on the right-hand side of the equation. So negative 24 minus 15 is negative 39. And then, whoa, look at that. We actually have a statement here. Now look at this statement. We have 0 equals negative 39. Well, I think you understand that 0 is not the same thing as negative 39, right? So this is actually not true. This is a false statement. So whenever we have a false statement, you need to make sure that you write these two words. No solution. No solution just means that no x and or y value will make both of these equations true at the same time. All right. Let's move on to number 4. Ooh, we have 56x plus 8y equals negative 32, and 7x plus y equals negative 4. All right, so if I look at the x's, we have 56 and 7. That's just way too much for me, and 56 and 7 are large numbers, and those numbers I don't want to deal with. But if I look at 8y and y, right, the y values here, I'm going to manipulate the second equation. So what I'm going to do here is I'm actually going to multiply each term of this equation here by negative 8. Because look, we have positive 8y, and once I distribute the negative 8 to each term, this is going to become, well, negative 8 times 7x is negative 56x, okay. And then negative 8 times y is negative 8y. And negative 8 times negative 4 is positive 32. So, let's rewrite this. I have 56x plus 8y equals negative 32. And then we're going to go ahead and add vertically. Positive 56x and negative 56x. Those are opposites, actually 0. Positive 8y and negative 8y. Those are opposite. That's another 0. And then negative 32 plus 32 is also 0. So I have a 0 equals 0 situation. There are no variables, and we have a statement. And of course, this statement is true because 0 is 0. So this is a true statement. Therefore, since this is a true statement, we say that this solution has infinitely many solutions. And that's your answer for number 4. You can also write all real numbers if you would like, and you can use this symbol, this weird looking R, to put as your answer, or you can say IMS. Either works. Second to last problem, we have 3x plus 5y equals negative 19, and positive 2x plus 3y equals negative 9. Now, the trickiest thing about number 5 is that we are so used to multiplying each term by a certain number for one equation, and we were able to create opposites that way. However, that's not the case with number 5 because there is no coefficient of 1 anywhere. So if we look, we have 3x and 2x, we have 5y and 3y, and then we have negative 19 and negative 9, but we don't really care about the constants. We're focusing in on the x's and y's. So, again, what I'm trying to say here is none of these terms have a coefficient of the number 1, right? We have, again, 3, 5, 2, and 3. So, how do we create opposites when there isn't a 1 anywhere? Well, what we need to do is we need to understand least common multiples, meaning if I were to choose either x or y, let's focus in on the x's, we have 3 and 2. What is the lowest number that 3 and 2 go into at the same time? Well, if we think, okay, well, the least common multiple that I think of is 6, right? So we know that 3 times 2 is 6, or 2 times 3 is 6. Now, I can also say the same thing if I were to look at 5y and 3y, or just specifically the 5 and the 3. The least common multiple for 5 and 3 is 15, because 5 times 3 is 15, and 3 times 5 is 15. So let's go ahead and use that idea to solve this system. What I'm going to do is I'm going to focus in on the x's. I'm going to create my opposites by eliminating the x's. So what I'm going to do is I'm going to multiply the first equation by negative 2. And then I'm going to multiply the second equation by positive 3. Remember, when you're creating opposites, one has to be negative and the other has to be positive, or vice versa. One can be positive and the other must be negative, however you want to approach that scenario. So what I'm going to do is I'm going to distribute the negative 2 to each term of the first equation. So negative 2 times positive 3x is going to give me negative 6x. Negative 2 times positive 5y is negative 10y. Negative 2 times negative 19 is going to give me positive 38. And then what I'm going to do now is I'm going to multiply the 3 to each term of the second equation, and that's going to give me 3 times 2x, that's positive 6x. 3 times positive 3y is 9y, and 3 times negative 9 is negative 27. Now, I'm going to go ahead and add vertically each time. So if we look at the x's, we created the opposites already, so we can go ahead and cancel them out. And we're left with negative 10y plus 9y, which is going to be negative 1y, or just negative y, equals 38 minus 27. That is going to be 11. And then I will divide both sides by negative 1. And that is going to give me y is equal to negative 11. Now, we know that y is equal to negative 11. If I were to substitute the y value in one of the equations in my system, then that's going to help me find my x value. So I can choose whatever equation I want. I can choose the first one or the second one. I'm going to choose the second one because that one looks a lot easier to work with than the first one. You just have to believe me on this one. So since I know that y is equal to negative 11, and I'm using the second equation, I have 2x plus 3 times negative 11 is equal to negative 9. So 2x, and then positive 3 times negative 11 is negative 33 equals negative 9. I'm going to add both sides by 33. And that's going to give me 2x equals negative 9 plus 33 is 24. And then I will divide both sides by 2. So x equals 12. I know my x value and I know my y value. So 12, comma, negative 11. That is the solution to number 5. Number 6, 2x plus 3y is equal to 12. And 8x minus 6y is equal to 12. So you can choose to eliminate the x's or the y's. I'm going to eliminate the y's this time. And what I'm going to do is multiply this whole equation by 2. So then I'm going to distribute. I have 4x plus 6y equals 24. And then I'm going to rewrite the second equation. I have 8x minus 6y equals 12. And the reason why I chose the first equation to multiply by positive 2 is because I have a positive and a negative. And once I distribute the 2 to each term, this is going to become positive 6y. And I have that negative 6y in the other equation. And that will form the opposites. So let's go ahead and add vertically. Positive 4x and 8x. If I combine those two terms, we know that's going to be 12x. And then positive 6y and negative 6y, they will cancel. And then positive 24 and 12. If I were to add those two numbers together, that is going to give me 36. So now let's divide both sides by 12. I get x equals 36 divided by 12 is 3. So if x is equal to 3, let's go ahead and plug that into the first equation. So 2 times 3 plus 3y equals 12. 2 times 3 is 6 plus 3y equals 12. Subtract both sides by 6 here. 3y equals 6. And then I will divide both sides by 3, so y equals 2. So as an ordered pair, 3, 2 is the solution to this system.